Section 4.6 Threading issues. First, fork and execute system calls. We already knew that the fork system call is used to create a separate duplicate process. The semantics of the fork and execute system calls change in a multi-threaded program. If one thread in a program calls fork, does the new process duplicate all threads, or is the new thread process single-threaded? Some UNIX systems have chosen to have two versions of fork, one that duplicates all threads and another that duplicates only the thread that invoke the fork system call. The execute system call typically works in the same way as described in the above section. That is, if a thread invokes the execute system call, the program specified in the parameter to execute will replace the entire process, including all threads. Which of the two versions of fork to use depends on the application. If execute is called immediately after forking, then duplicating all threads is unnecessary, as the program specified in the parameters to execute will replace all processes. In this instance, duplicating only the calling thread is appropriate. If, however, the separate process does not call execute after forking, the separate process should duplicate all threads. Second, signal handling. Signal handling. A signal is used in UNIX system to notify a process that a particular event has occurred. A signal may be received either synchronously or asynchronously, depending on the source of and the reason for the event being signaled. All signals, whether synchronous or asynchronous, follow the same pattern. First, a signal is generated by the occurrence of a particular event. 2. The signal is delivered to a process. Third, once delivered, the signal must be handled. Synchronous signals are delivered to the same process that performs the operation that caused the signal. That is the reason they are considered synchronous. When a signal is generated by an event external to a running process, that process receives the signal asynchronously. Examples of such signals include terminating a process with specific keystrokes and having a timer expire. Typically, an asynchronous signal is sent to another process. A signal may be handled by one of two possible handlers: a default signal handler, a user-defined signal handler. Every signal has a default signal handler that the kernel runs when handling that signal. This default action can be overridden by a user-defined signal handler that is called to handle the signal. Signals are handled in different ways. Some signals, such as changing the size of a window, are simply ignored. Others, such as an illegal memory access, are handled by terminating the program. Handling signals in single-threaded program is straightforward. Signals are always delivered to a process. However, delivering signals is more complicated in multi-threaded programs, where a process may have several threads. Where then should a signal be delivered? In general, the following options exist. First, deliver the signal to the thread to which the signal applies. Second, deliver the signal to every thread in the process. Third, deliver the signal to certain threads in the process. Fourth, assign a specific thread to receive all signals for the process. The method for delivering a signal depends on the type of signal generated. For example, synchronous signals need to be delivered to the thread causing the signal and not to other threads in the process. However, the situation with a synchronous signal is not as clear. Some asynchronous signals, such as a signal that terminates a process, should be sent to all threads.